Hi my dear friends, welcome back to our YouTube channel. This is your ADC. Welcome back to our YouTube channel ADC Max. In this class, I am going to classify the second order partial differential equations. What is second order partial differential equation? So before going to that, I just compare this with the help of the quadratic equation. So I think so all of you may know what is the quadratic equation. Ax squared plus bx plus c is equal to 0. Is right? Am I right? What is A? A is the coefficient of x squared, b is the coefficient of x, and c is the constant term, isn't it? Now, how to get the roots of this quadratic equation? There is one formula is there, it's called quadratic formula. X is equal to minus b plus or minus square root of b squared minus 4ac by 2a. Is right? What is the A? A is the coefficient of x squared, b is the coefficient of x, and c is the constant term. And by using this quadratic formula, we may get the roots of this quadratic equation. It's clear? Now, in this formula, the nature of the roots can be decided only depends on this value. What's the name of this one? This is called the discriminant value. This is often called as discriminant value. So this discriminant value b squared minus 4ac will decide the roots of the given quadratic equation. What are the nature of the roots? Suppose this b squared minus 4ac is positive, then the roots are real and distinct. Suppose the roots, the b squared minus 4ac value is equal to 0, then the roots are real and equal. Suppose the b squared minus 4ac discriminant value is negative, then the roots are complex. So the nature of the roots only depends on this discriminant value b squared minus 4ac. So the same concept I am going to use in the classification of second order partial differential equation. The same idea exactly. Now let us consider the second order partial differential equation with the constant coefficient is of the form a into dou square z by dou x square plus b into dou square z by dou x dou t. Sir, I am considering here z be the function of x and t. Z be the function of x and t. Right? Suppose z be the function of x and y means it will be changed accordingly. Now, dou square z by dou x square plus b into dou square z by dou x dou t plus c into dou square z by dou t square plus d into dou z by dou x plus e into dou z by dou y plus f is equal to a function of x comma t. Now, what is A? A is the coefficient of z with respect to x 2 times. With respect to x 2 times. So this is the second order partial differential equation. We only concentrate on the coefficients of second order partial derivatives. We don't bother about the first order partial derivatives, namely like d, e, f, we don't bother. We only collect or pick the coefficients of second order partial derivatives. Here a is the coefficient of z with respect to x 2 times. What about b? B is the coefficient of the second order partial derivative. Z with respect to x 1 time, with respect to t 1 time. It's called mixed partial derivatives. So this is the B. What about C? C is z with respect to t 2 times. So we only focus on these 3 coefficients. With respect to the first variable 2 times A, with respect to the second variable 2 times C, with respect to first variable 1 time, second variable 1 time, it is called B. That's called mixed partial derivatives. So with the help of these 3 coefficients, coefficients A, B, C, it can be classified the second order partial differential equations into the three types. What are they? Yeah, as I told you that the same discriminant value it influence in this side. So what is the discriminant value? B squared minus 4AC. Suppose B squared minus 4AC value is negative, then it is called elliptic. Suppose B squared minus 4AC is equal to 0, then the given second order partial differential equation is of parabolic type. Suppose B squared minus 4AC is positive, then it is called hyperbolic. So B squared minus 4AC is the value. There are three possible values: negative, elliptic, is equal to 0, parabolic, it is positive, hyperbolic, which is equal to the nature of the roots in the quadratic formula. That is B square minus 4AC is positive, it is real and distinct, is equal to 0, real and equal, is less than 0, that is negative, we get the complex roots. So second order partial differential equation, we focus only on the second order partial derivatives. A is the variable with respect to first variable with respect to 2 times first variable. B is first variable 1 time, second variable 1 time, and C is second variable 2 times. That's it. We don't bother about the other first order partial derivatives and the right hand side functions, whatever so given in the given second order partial differential equation. So we only focus on the second order partial derivatives. With the help of A, B, C, determine the value of B squared minus 4AC. If it is negative, the equation is elliptic, is equal to 0, it is parabolic, it is positive, then we may say that it is the hyperbolic equation. Now, we are going to discuss a few important equations of the examples of the hyperbolic, parabolic and the elliptic type. What are those equations? So the first one I am considering one-dimensional wave equation. One-dimensional wave equation. What is one-dimensional wave equation? One-dimensional wave equation, that is dou squared y by dou t squared is equal to a squared into dou squared y by dou x squared. Are you saying that this is second order partial differential equation? Yes, of course. What about y? Here y be the function of x comma t. This is called the displacement function of the one-dimensional wave equation. Now my question is whether is of any one of the type. Let us check it out. So now can I rewrite this equation by a squared dou squared y by dou x squared minus dou squared y by dou t squared is equal to 0. Is right? Now y be the function of x. So when we differentiate y with respect to x 2 times, so by that way capital A is small a square, because a is the coefficient of the second order partial derivative first variable with respect to 2 times. Got it? What about b? B is first variable 1 time, second variable 1 time, that is dou squared y by dou x dou t, but there is no such terms present in this equation, so 0. What is c? C is nothing but the y with respect to t, the second variable 2 times, that is dou squared by dou t squared is there. What about the coefficient? It is minus 1. So once we found the ABC value, let us determine the value of b squared minus 4ac. So b value is 0, 0 squared, 4 into a value, a squared, c value minus 1. I think minus of minus is plus 4. So this is plus 4a squared. It is always positive because a squared is always positive, isn't it? Square value. So once b squared minus 4ac is always positive, so what type of this equation is? This is the elliptic type or parabolic or hyperbolic? Yeah, what says here? B squared minus 4ac is positive, that is called the hyperbolic. So this is an example for hyperbolic type equation. So this is the hyperbolic type equation. So this is the one-dimensional wave equation. Now what is the example for parabolic type? Let us see. I am considering the parabolic type now. The parabolic equation is, the example for parabolic equation is one-dimensional heat flow equation. One-dimensional heat flow equation is the simplest example for parabolic type. How? Let us see that. What is the one-dimensional heat flow equation? Dou u by dou t is equal to alpha square into dou square u by dou x square. Is this a second order partial differential equation? Yes, because of I have one partial derivative up to the second order. What about the left hand side? It's the first order. We don't bother about the first order partial derivatives. Is right? So here u be the function of x comma t. This is called the required temperature distribution. This is called the required temperature function of the given heat flow equation. Now, whether this is the elliptic type or parabolic type or hyperbolic type. So first we can collect the second order partial derivatives coefficients. So what is A? A is u with respect to x 2 times. So we have, yes, I think so, this is alpha square. What about B? B is u with respect to x 1 time, u with respect to t 1 time. That means that dou square u by dou x dou t, but there is no such terms present in this equation. So B is 0. What about C? C is u with respect to t 2 times. So that's second order. Only we focus on second order. So this is the first order. So we don't consider this term. So once again, there is no dou squared y by dou t squared. So C is also 0. Isn't it? Isn't it? B 0, C 0. Only A is there. What's the A? Alpha squared. It's a positive value. Now let us see what is the B squared minus 4AC value. B squared minus 4AC is B squared is 0. A value is alpha squared. C value is 0. So once again this is 0. So once B squared minus 4AC is 0, then this is called the parabolic type equation. So one dimensional heat flow equation is an example for parabolic type. Isn't it? Parabolic type. Now what about the balance? So one dimensional wave equation is hyperbolic type. One dimensional heat is parabolic type. So what about the elliptic type? Yeah, the elliptic type, I can extend one dimensional into the two dimensional heat flow equation under the steady state. Under the steady state. So under the steady state, the two dimensional heat flow equation is often called as Laplace equation. Laplace equation in the Cartesian coordinates is nothing but dou square u by dou x square plus dou square u by dou y square is equal to 0. So this is known as Laplace equation or steady state equation in two-dimensional heat flow equation. Two-dimensional heat flow equation in steady state is often called as Laplace equation. Is it second order partial differential equation? Yes, of course, because there are two terms, both are second order. What about here u? U be the function of x and y. Is that correct? Right, sir? So what about capital A now? Capital A is u with respect to x 2 times is there. Is 1. Coefficient of dou square u by dou x square is 1. What about B? B is u with respect to x 1 time, y 1 time. But there is no such terms present here. So 0. What about C? C is u with respect to y 2 times is there. Dou square u by dou y square is 1. So A1, B0, C0. Now what about the B squared minus 4AC value? B squared minus 4AC is B squared is 0. So 0 squared minus 4 into 1 into 1. So the answer is minus 4. Minus 4 is the negative. So B squared minus 4AC is negative. So what we say, we call it as the equation is elliptic type. So this is the example for elliptic type equation. This is the elliptic type equation. So once again I repeat this. Classification of second order partial differential equation is mainly focused on the coefficients of the second order partial derivatives. Here A is the first variable with respect to 2, B is the coefficient of first variable one time, second variable one time, C is the second variable 2 times. So we don't bother about the other first order partial derivatives and etc. etc. Now let us find the b squared minus 4ac value. If it is negative, elliptic is equal to 0, parabolic is positive, it is hyperbolic. The example for hyperbolic is one-dimensional wave equation. The example for parabolic is one-dimensional heat flow equation. The example for elliptic is, two-dimensional heat flow equation under the steady state is often called as Laplace equation. Got it? Thank you so much for watching our YouTube channel. Please kindly support our YouTube channel. This is your YouTube channel, ADC Max. Thank you so much. Signing off. Bye bye. Take care.